Wear lab coat, gloves, and goggles all times. Do not heat the paraffin over direct flame. Use ventilation when working with solvents and oils.
In this lab, the main element we worked with was paraffin, which allows us to better understand alkyne compounds and how they react to various factors, such as direct heat or substances like ethanol. The learning process was prepared by the creation of a candle, which allows us to better understand a common everyday element. First, the paraffin was observed and analyzed, and then its solubility in water, ethanol, and acetone was tested. Subsequently, the entire candle making process began. The paraffin was melted and dyed, and essence oil were added to enhance the candle aesthetic and to understand how the different elements interact. Finally, the paraffin was placed in a mold along with the cotton wick, allowed to cool and solidify. And then we removed the mold, and the candle was made. Paraffin, alkane, solubility.
To identify the chemical properties of paraffin as an alkane, analyzing its structure, solvent behavior, and combustion reaction. Additionally, apply organic chemistry concepts to create aromatic and colored candles, exploring the chemical nature of fragrances and colorants. Paraffin is a waxy substance derived from petroleum, composed mainly of long-chain alkanes. As part of the study of organic chemistry, this lab aims to identify the chemical properties of paraffin as an alkane by observing its structure, its behavior in different solvents, and its combustion reaction. In addition, the goal is to apply this knowledge in the creation of aromatic and colored candles, analyzing the solubility of colorants and the release of fragrances through heat. This hands-on experiment allows us to connect concepts such as polarity, solubility, and complete versus incomplete combustion with observable phenomena, promoting a better understanding of how hydrocarbons behave in everyday life.
Combustion test step by step. To carry out the combustion test, we'll need the candle we previously made and a lighter. Step 1. First, we'll light the candle carefully using the lighter. Step 2. Then we closely observe the flame. Pay attention to its color since it provides key information about the depth of combustion. Step 3. Next, we observe if there is any soot being formed. Soot is a sign of incomplete combustion. Step 4. We also pay attention to how the candle behaves in terms of scent and flame color while it's burning. At step 5, based on what we see, we determine whether the combustion is complete or incomplete. A complete combustion is indicated by a blue or yellow flame. In contrast, if there is a soot or there is a flame or the flame is orange, the combustion is incomplete. Final step. Finally, we write down our observation and analyze the results obtained during the test. Physical and chemical properties of paraffin. This diagram explores the basic properties of paraffin. First, we observe its color, odor, and state. Then, we melt the paraffin using a double boiler and record its melting point. Next, we test its solubility by mixing pieces of paraffin with water, acetone, and ethanol, recording all the results. And this allows us to compare how paraffin behaves with different solvents and understand its chemical characteristics. Diagram of colorants. This diagram explains how to add color to paraffin. We start with either a synthetic or natural colorant. A small amount is added to the melted paraffin, and after mixing, we check if the color adhered properly. As an optional step, we may also create our own natural extract to experiment with alternative color sources. Chemistry of fragrance. This diagram focuses on how fragrances are released from paraffin. We begin by adding 5 to 10 drops of an essential oil, such as lavender, mint, or vanilla, into the melted paraffin. Then we observe how the essence is released by heat and finishing by discussing the chemical nature of these aromatic compounds.
Process of pillar candle. First, grade your materials: paraffin, wax, candle wicks, a pot of burning junk, thermometer, aromatic oil, dye, and round pillar mold. Start by preparing your mold and inserting the wick. Then wait and melt your wax using a double boulder. Once melt, add about 1 ounce of fragrance, oil, and your choice dye. Feel free to get creative with the colors. Now check the temperature. If the wax is at 88 Celsius, pour into the mold and let it cool. If not, wait until it reaches the temperature. Once set, carefully remove the candle from the mold and trim to the wick around 6 millimeters. And that's it. You must make your own homemade pillar candles.
Results. In Part A, we first examined the paraffin in its solid state. It was white, opaque, and had no noticeable smell. When we melted it using a double boiler, we recorded a melting point of around 55 degrees Celsius. Then we tested the solubility. In water, the paraffin was insoluble and just floated. In ethanol, it barely dissolved, but in acetone or hexane, it dissolved well, proving it's a non-polar substance just like other alkanes. In Part B, we added a few drops of essential oils. As expected, the heat released the fragrance into the air. These scents come from volatile organic compounds that evaporate when heated, allowing us to smell them. In Part C, we tried adding both synthetic and natural colorants. The synthetic dyes mix much better with the wax. The natural colorants, especially those dissolved in water, didn't mix well, but when we use alcohol-based extracts, the results improve a bit. For Part D, we poured the wax into molds with cotton wicks and let it cool to create our own candles. The color and scent were preserved, though a bit weaker once the wax was solidified.
After completing our candle making experiment, we was able to analyze how the physical and chemical properties of each material affect the process. For example, paraffin had a density of 0.91 grams and melting point between 58 and 82 Celsius, making it ideal for melting and cooling. Essential oils with a density of 0.85 grams and very low boiling point evaporate quickly, which explains why the fragrance was strong at first but faded over time. Colorants were the only material that showed a physical change because when it gets to the paraffins, change by a physical change with the colors. Next, when we mix paraffin with ethanol, we see a visible change between the soluble most of the materials, where that insoluble with water and had very low conductivity and no magnetic properties. Based on the data, we can conclude that the materials selected were appropriate and the behavior observed matched their properties. This supports the hypothesis and shows a clear connection between the material's properties and their function in the candle making. It also highlights the importance of understanding physical and chemical characteristics when designing real-life applications like the making candle. Questions and answers. What chemical properties identify paraffin as alkyne? Paraffin is made by saturated hydrocarbons alkynes with only single CC and CH bonds. It is a nonpolar chemical stable and bursts into oxygen to form CO2 and H2O. Next question. What do you observe regarding solubility and polarity? Paraffin was insoluble in water and ethanol polar solvents, but soluble in acetone or hexane nonpolar covalents, confirming that is a nonpolar. What type of compounds are responsible for the fragrance? Fragrances come from volatile organic compounds like esters, terpenes, and alcohols found in essential oils, which evaporate with heat. Which colorant work best? Were they soluble in wax? Oil-based or synthetic wax colorants work best. They dissolve well in milk paraffin, while water-based ones didn't mix properly. Were you able to produce your own colorants? What were the results? No, we did not produce our own colorants. We used power commercial colorants which mix well with the wax. What kind of combustions occurred? What products were formed? Mostly incomplete combustions occurred shown by a yellow flame and shoot products including CO2, H2O,